3. Okay, our topic is linear programming, and the question is: a grocer buys cases of walnuts and almonds. Almonds are packaged 20 bags per case. The grocer pays $30 per case of almonds and makes a profit of $17. Walnuts are packaged at 24 bags per case. The grocer pays $26 per case of walnuts and makes a profit of $15 per case. He orders no more than 30 bags of almonds and walnuts together at a maximum cost of $400. How many cases of almonds and walnuts maximize the grower's profit? Okay, so our first step is to define the variables. So our variables are walnuts and almonds. So for almonds, we'll use A, and for walnuts, we'll use W. After this, we have to write the constraints. So we know that A and W can't be less than 0, so A has to be greater than 0 and W has to be greater than 0. After this, we know that each almond is packaged at 20 bags per case, so we do 20A, and that walnut is packaged at 24, so that's plus 24W. And so this actually has to be equal to 0 or greater than 0, and then it's 20A plus 24W. It has to be greater than or equal to 300 bags because they can have no more than 300 bags. After that, we know that the grocer pays 30 for almonds and 26 for walnuts, and he can buy no more than 400. So that would be 30A plus 26W, and it has to be greater than or equal to 400. Be less than 400.
So when she was explaining, these are called the constraints. So basically, it's basically inequalities. So what we are going to do is that we are going to graph these constraints on the actual graph. So we know A is the almonds, and we know that he has to buy greater than or equal to 0. So what we're going to do is that this is going to be your A, so this is technically X, but let's make it A. And your walnuts are W, and let's make that your Y, but we know that that's your walnuts. So we know that A has to be greater than or equal to 0. So we're going to make this your A. And this is where you graph. This is basically graphing your constraint. And then you are going to graph your W is greater than 0, greater than or equal to 0. So we're going to graph all of this. And then you are done with the first two. Then now when you're trying to solve what else to graph here, you're going to basically take that 20A plus 24W is less than or equal to 300. And you're going to get the A by itself and the W by itself. So it's 20A plus 24W is less than or equal to 300. So then what you're going to do is you're going to subtract 24W minus 24W on both sides. This is going to be 20A is less than or equal to negative 24W plus 300. Then you are going to divide the 20 to get that A by itself. So A is going to be, A is less than or equal to negative 1.2 W plus 15. So then now you're going to graph that one, and you're going to go to 15, which is right here. And you are going to go down with the slope of negative 1.2 W. And when you go all the way down here, you're going to get up to 13. And it's a straight line down here. And then when you're going to do the W, it's 20A plus 24W is less than or equal to 300. And then this time, instead of subtracting the negative 24, you're going to do negative 20 because you're trying to get this one by itself. So negative 20A minus negative 20A, and this becomes 24W is less than or equal to negative 20A plus 300. Then you're going to divide by 24 to get that W by itself, and you are going to get negative 5 over 6A plus 12.5. So for this one, let's use green. So we're just going to use this one as green so you guys can see it. And you're going to start up at 12.5. It's around here. And then you are going to go all the way to 515. We need to do all the math. Okay, so we see this intersection. So we see that this is basically the festival area, or festival region. So what you are going to do is that you're going to shade this entire area, because these are all possible solutions. So what's in this area, you are going to find the vertices. So this is one vertice, then you keep going down. This is 2, this is 3, and this is 4. These are your 4 vertices. This is basically your graph with the constraints. These are your vertices, and this is your festival region. So now what you're going to do is you are going to list your vertices as your step 4. So let's go down here. So your vertices are 0, 12, because you go up here, it's 0, 12. Then your next vertex is 5, 9. 5, 9 is right around here. Oh, should have been over here. Okay. The next one is 13, 0, which is exactly right here. And your 0, 0, which is right all the way over here. So we recorrected the graph because it was a little off, and we used straight edges this time. So right here is where you can see the intersection between the 2 constraints. So then for step 5, you have to actually create a function or a constraint that needs to be either maximized or minimized. In this case, it's maximized because we're trying to see what can max the profit. So back in the problem, it said that, so we're going to find the profit. So this is basically what this P means. It stands for profit. And in the problem, it said that the store owner makes $17 profit per almond case, and they have $15 profit per walnut.
Okay, so for your step 5, you're gonna make a function, which is 17a plus 15w. That's gonna be your profit for your sales on almonds and walnuts. It's gonna be 17a. Alright, so it's gonna be 17a plus 15w because you're gonna have 17 profit for each almond and 15 profit for each walnut. And so you're gonna bring your function down here for this table, and you're just going to rewrite it with these vertices in the function. Alright, so here you're plugging in the 0 and the 12 into these because here this is the A and this is the W. So then you're gonna have this equation here, and this actually solves out to 180. And we're just gonna do that for each of the vertices now. 5 into this one, and 9 into this one. And this one actually adds up to 220. Here it's gonna be 17 times 13 plus 15 times 0. This one will be 221, and this one's gonna be 0, 0. So it's just gonna be, that, and it's obviously gonna be 0. So out of all of these, this one is the highest, but it can't be our answer since we need both almonds and walnuts bought, and this one does not have any walnuts. So we're gonna go to our second biggest that has both walnuts and almonds, which is gonna be this one, 220. So for step 7, we're just gonna write our answer, and it's gonna be 9 cases of almonds and 5 cases of walnuts. Go!
Okay, so our topic is linear programming. Walnuts are packaged, 24 per case, and the... You have to start it.
Gee.
It tells you how much they have left.
I know. I doubt that we'll pass 25.
And that has to be greater than... No, the maximum has to be 400. Hold up, pause it. It's because I ended here, so it's like... Okay.
Since it's 17 profit for your almonds, and 15W because it's gonna be 15 profit for your walnuts. And stop right there. It's gonna be 17A plus 15W because you have 17 profit for each almond and 15 profit for each walnut. Or almond. Yo. So yeah, let's do it. Wait.